Hello viewers, in our previous lessons we have already learned to solve quadratic equation by factorization method and by using formula. We also learnt about properties and nature of roots of a quadratic equation. What else did we learn? We learned to solve few equations which were not of quadratic form but which can be reduced to quadratic form by simple manipulations. For example, we saw that equation of the form a z raised to the power 4 plus b z square plus c equal to 0 can be reduced to quadratic form by simple substitution x is equal to z square, and this equation in that case becomes ax square plus bx plus c equal to 0, which is of quadratic form. In this lesson today we are going to take up few more such cases. Look at the equation under root 3x square minus 2 is equal to 2x minus 1. Now look at this equation carefully. The left hand side of this equation is positive square root of 3x square minus 2. Also 3x square minus 2 should be non-negative because in real numbers there are no square root of negative numbers. That is, x square should be greater than or equal to 2 by 3. Also, since left hand side of this equation is non-negative, therefore right hand side of this equation will also be non-negative. That means 2x minus 1 should also be greater than or equal to 0, or x is greater than equal to half. So we have to find solutions such that they satisfy the conditions x square is greater than equal to 2 by 3 and x is greater than equal to 1 by 2. Now how do we remove this radical sign? Let us square both sides of this equation. What do we get? Let us see. The left hand side we get 3x square minus 2 on squaring, and the right hand side of the equation becomes 4x square minus 4x plus 1. Taking these terms to the right hand side of the equation, we get 4x square minus 3x square minus 4x plus 1 plus 2 equal to 0, which can be further simplified, and we get the final equation as x square minus 4x plus 3 equal to 0. Now this equation is of quadratic form, and we know how to solve a quadratic equation of this form. The factors of this equation will be x minus 1 into x minus 3 equal to 0, and hence the solutions of this equation will be x is equal to 1 and x is equal to 3. But do these values of x satisfy our condition x square greater than equal to 2 by 3 and x greater than equal to half? Let us see. When we have x is equal to 1, then we find that 1 square is naturally greater than equal to 2 by 3 and 1 is greater than half. So x is equal to 1 satisfies these two of our condition. Secondly, when we take x is equal to 3, then putting here 3, we get 3 square, that is 9. 9 is greater than 2 by 3 obviously, and 3 is greater than half. So, thus we find that both x is equal to 1 and x is equal to 3 satisfy our conditions. Therefore, x is equal to 1 and x is equal to 3 will be the solutions of this equation under root of 3x square minus 2 equal to 2x minus 1. Look at another equation. Under root of 4 minus x plus under root of x plus 9 equal to 5. When we observe this equation carefully, we find that there are two expressions involving radical sign. Also, both these expressions are positive square roots of 4 minus x and x plus 9 respectively. And we also find that this 4 minus x should be non-negative, because in real numbers there are no square roots of negative numbers. That means x is less than or equal to 4. Also, x plus 9 should be non-negative. By the same reasoning, that means x is greater than or equal to minus 9. Combining these two conditions, we can write this as x is greater than or equal to minus 9 and less than equal to 4. So, thus we have to find solutions of this equation so that they satisfy the condition x greater than or equal to minus 9 and less than or equal to 4. Now, how do we remove these two radical signs? Let us square both sides and see what do we get. Before squaring it, let us take one of the expressions involving radical sign to the right hand side. That will make our work easier. What do we get? We have 4 minus x is equal to 5 minus under root of x plus 9. Now, squaring both sides of this equation, we get 4 minus x is equal to 25 plus x plus 9 minus 10 under root of x plus 9. Now, taking these expressions to the left hand side, that means those expressions which do not have radical sign, to the left hand side we have 2x plus 30 is equal to 10 under root of x plus 9. Dividing throughout this equation by 2, we finally get x plus 15 is equal to 5 under root of x plus 9. But what do we have here? We again get an equation which has an expression involving a radical sign. And how can we remove this radical sign? Let us again square this expression both sides and see what do we get. When we square both the sides of this equation, we get x square plus 30x plus 225 is equal to 25 into x plus 9. Taking all these terms to the left hand side, we finally get the equation as x square plus 5x equal to 0, or x into x plus 5 equal to 0. That means either x is equal to 0 or x plus 5 equal to 0, that is x is equal to 0 and x is equal to minus 5. So, x is equal to 0 and x is equal to minus 5 are the solutions of this quadratic equation x square plus 5x is equal to 0. but do these values of x satisfy our condition x greater than equal to minus 9 and less than equal to 4? Let us see. When x is equal to 0, then putting in this condition we have minus 9 less than equal to 0 less than equal to 4. That means x is equal to 0 satisfies this condition. Also, when x is equal to minus 5, we have minus 9 less than equal to minus 5 less than equal to 4. So, again we have x is equal to minus 5 satisfying this condition, and thus we conclude that x is equal to 0 and x is equal to minus 5 are the solutions of this equation under root of 4 minus x plus 9 under root is equal to 5. Now, look another equation, 3 multiplied by x square plus 1 upon x square minus 16 x plus 1 upon x plus 26 equal to 0. Observe this equation carefully. Is it a quadratic equation? No, it is not. But the question is, can we solve this equation by reducing it by some manipulation to a quadratic form? Let us see. If we substitute y is equal to x plus 1 upon x, then what will be the value of x square plus 1 upon x square in terms of y? For that, let us square both sides of this equation. Squaring, we get y square is equal to x square plus 1 upon x square plus 2, or we get y square minus 2 is equal to x square plus 1 upon x square. Thus, we find that if we substitute x plus 1 upon x as y, then x square plus 1 upon x square will be y square minus 2. So, replacing x plus 1 upon x by y and x square plus 1 upon x square by y square minus 2, let us see what do we get. We get 3 times y square minus 2 minus 16y plus 26 is equal to 0. Removing this bracket, we get the final equation as 3y square minus 16y plus 20 is equal to 0. Now, this equation is of quadratic form. Can you tell what will be the factors of this equation? Yes, the factors of this equation will be y minus 2 into 3y minus 10 equal to 0, and hence we get two values of y, that is y is equal to 2 and y is equal to 10 by 3. But we want the value of x because the equation given to us was in x. So, again replacing this y by x plus 1 upon x, we get x plus 1 upon x is equal to 2. Now, we have solved equation of this type in our earlier lesson, that is equation of the form ax plus b upon x is equal to c, if you remember correctly, where x is not equal to 0. Now, solving this equation, we get x square minus 2x plus 1 equal to 0. The factors of this equation will be x minus 1 into x minus 1 equal to 0, or we get x is equal to 1, x is equal to 1, that means we get real and equal roots. Also, when we replace y as x plus 1 upon x, what do we get? X plus 1 upon x is equal to 10 by 3 in this case, and this equation becomes 3x square minus 10x plus 3 equal to 0. The factors of this equation will be 3x minus 1 into x minus 3 equal to 0, and hence we get x as 1 by 3 and x is equal to 3. So, we get 4 solutions of this equation. The solutions are x is equal to 1, again x is equal to 1, then x is equal to 1 upon 3 and x is equal to 3. Why do we get 4 solutions of this equation? Because if you look at this equation, x square plus 1 upon x square, that means this is a biquadratic equation and hence it will have 4 solutions. Thus, we find that we can solve equation of the form a x square plus 1 upon x square plus b into x plus 1 upon x plus c equal to 0 by simple substitution x plus 1 upon x is equal to y. Similarly, we can solve equation of the form x square plus 1 upon x square plus b into x minus 1 upon x plus c equal to 0 by the substitution x minus 1 upon x equal to y, and in this case this equation will again reduce to quadratic form and we can solve that equation by our knowledge. Now, look at another important type of equation. 9 x plus 2 minus 6 times 3 raised to the power x plus 1 plus 1 equal to 0. Now, observe this equation carefully. Is it a quadratic equation? No, again it is not a quadratic equation. But can we reduce this equation to quadratic form? Let us see. Let us simplify this equation. We get 9 raised to the power x multiplied by 9 raised to the power 2 minus 6 times 3 raised to the power x into 3 raised to the power 1 plus 1 equal to 0. That is 81 into 9 raised to the power x minus 18 into 3 raised to the power x plus 1 equal to 0. Now, suppose we replace this 3 raised to the power x or substitute y as 3 raised to the power x. Then what will be the value of 9 raised to the power x in terms of y? We know that 3 square is equal to 9. That means if 3 raised to the power x is equal to y, then 9 raised to the power x can be written as 3 square raised to the power of x. Now, since we know that in real numbers multiplication is commutative, so I can write this as 3 raised to the power x whole raised to the power of 2. And since 3 raised to the power x is y, so this expression can be written as y square. Thus, we find that if we substitute 3 raised to the power x as y, then 9 raised to the power x can be written as y square. So, replacing 9 raised to the power x as y square and 3 raised to the power x as y, we get the equation as 81 y square minus 18 y plus 1 equal to 0. Now, the factors of this equation will be 9y minus 1 again multiplied by 9y minus 1 equal to 0. So, in this case we get real and equal roots, namely y is equal to 1 upon 9. But again we want the solution in terms of x, because the equation given to us was in terms of x. So, what do? We replace this y by its original term, that is 3 raised to the power of x. So, we get 3 raised to the power of x is equal to 1 upon 9, or now this 1 upon 9 can be written as 3 square, which can be further written as 3 raised to the power of minus 2, and thus we find that 3 raised to the power x is equal to 3 raised to the power minus 2, which implies that x is equal to minus 2. Hence, this equation 9 raised to the power x plus 2 minus 6 into 3 raised to the power x plus 1 equal to 0 has solutions x is equal to minus 2 and again x is equal to minus 2, that is real and repeated roots. So, we found that few equations which are not of quadratic form can be solved by reducing them to quadratic form by simple manipulations. But now the question is, why do we solve quadratic equation? Does the knowledge of solving quadratic equation help us in solving any problem from our day to day life? The answer is yes. Let us see how. Consider the problem. A train covers a distance of 300 kilometers at a certain average speed. If its speed were decreased by 10 kilometer per hour, the journey would take 1 hour longer. What is the average speed of the train? Now, let us suppose that we have to solve this problem. For that, we again have to see what we are given in this question and what do we have to find. The first thing we are given in this question is the distance covered by the train, that is equal to 300 kilometers. And then we are given that if the speed is decreased by 10 kilometer per hour, then the journey will take 1 hour longer, and we have to find the average speed of the train. So, let us suppose that the average speed of the train is x kilometers per hour. Then we know that the time taken by this train in covering 300 kilometers of distance with the speed of x kilometers per hour will be equal to 300 upon x hours. But if the speed is decreased by 10 kilometers per hour, that means the new speed becomes x minus 10 kilometers per hour. Distance covered remaining same, the time taken in this case will be 300 upon x minus 10 hours. But according to the question, the time taken in this case is 1 hour longer than the time taken in the previous case. Now, in order to make these two timings equal, what do? We will write this equation as 300 upon x, but since this is 1 hour less, so we add 1 in order to equate it to the time taken by the train when its speed is decreased by 10 kilometers per hour. So, now this is our equation. And how do we solve this equation? 300 upon x minus 300 upon x minus 10 plus 1 equal to 0. Taking LCM, we get x into x minus 10, and here we have 300 into x minus 10 minus 300 into x plus x into x minus 10 equal to 0. Solving this equation and taking this expression to the right hand side, we get the final equation as x square minus 10x minus 3000 equal to 0. Now, again we find that this equation is of quadratic form, and we know how to solve a quadratic equation of this form. What will be the factors of this equation? The factors will be x minus 60 into x plus 50 equal to 0, and hence we get x is equal to 60 and x equal to minus 50. But we had taken x as the average speed of the train. Can the average speed of a train be in negative value? No. So, we rule out this possibility, and hence the average speed of the train will become 60 kilometers per hour, which was what we were asked to find. Consider the problem. The length of a rectangular hall is 5 meters more than its breadth. If the area of the hall is 36 square meter, then find the length and the breadth of the hall. Suppose we have to solve this problem. Before doing that, first of all we have to see what all conditions we are given in this question and what do we have to find. In this question, we are given that the length of the hall is 5 meters more than the breadth. Now, let us suppose that the breadth of the hall is x meters. Then, according to this condition given, we should have length of the hall is equal to x plus 5 meters. Now, we know that area of a rectangle is equal to length into breadth. So, area of the hall will be equal to x meters multiplied by x plus 5 meters. But in the question, we are already given that area of the hall is 36 square meters. So, we can write here 36 is equal to x square plus 5x. In other words, our equation becomes x square plus 5x minus 36 equal to 0, which is of quadratic form. Can you tell what will be the factors of this equation? This equation can be solved as x square plus 9x minus 4x minus 36 equal to 0, or x plus 9 into x minus 4 equal to 0. So that we get x is equal to minus 9 and x is equal to 4. But x being the breadth of the rectangle, it cannot be negative. So, we rule out this possibility, that is x is equal to minus 9, and hence we are left with the solution that x is equal to 4, that is the breadth of the rectangle, is equal to 4 meters. Now, before ending this lesson, let us have a quick recapitulation of what all we learnt in this lesson. We learnt to solve few problems which were not of quadratic form, but which can be reduced to quadratic form by simple manipulations. And we also saw the utilization of the solutions of quadratic equation in our day to day life. Thank you.